Yeah, in the last class we discussed spatial resolution. Yeah, but it is a spatial resolution. The satellites always, suppose example, if you feel it is a satellite, and then it's always revolved around the Earth, and it's releasing the different radiometric waves, and which are having a different wavelength. Then, in the presence of a passive sensors, I told you passive sensors and active sensors. No need to say again and again. Yeah. Passive sensors means natural radiation. In the presence of a natural radiation, the sun rays, it will fall on the object. If it is an object, thing. And again, little amount of percentage, approximately 17% absorbed by this objects, whatever it is, average, and then remaining again it will be reflected into the atmosphere. So, in the presence of these satellites, the satellite is mounted on bottom, which are having a sensors, and these sensors absorb the whatever reflected light it is released into the atmosphere. So here, spatial means it's making image. Slowly it is making an image. Slowly it is making image. There are various objects we have on an surface, like a plant, natural objects, and man-made objects, like the buildings, roads. Okay? These are all examples. So different objects are having observation capability. Then slowly it is making. So I tell you, like what it is. And again, it's mentioning some distance. These height, the height. Roughly, different satellites are maintained with different heights. For example, for geostationary. Geostationary. Yeah, geostationary. Geostationary. It's a Earth-based satellite. Geostationary almost it's a Earth-based satellite. Then sun synchronous satellites also there, and it will be working based on the sun radiation. One more, it is a polar region. Either maybe it is a northern polar or a southern polar, or sometimes maybe it is a northwest, southeast polar regions. Between that, the satellites which are moving. Then, when they are moving, the light, whatever it is reflected into the back, or it's towards, it's absorbing by the scanners, and slowly it is making the things or photos, whatever it is. Then, as per that, in electromagnetic spectrum, we have BFGR colors. That's maybe particularly we see blue, green, red. Okay, these three are major important waves, and which are having a wavelength that's 0.4 to 0.7 micrometers. No, not micrometers, nanometers on those. Then, in the presence of that, only some colors only we have a chance to identify. So, in the form of a spectral curve, you see here, it is a spectral curve. Then you can see here it's mentioning the wavelength. It's mentioning the wavelength. 0 point wavelength, it is maybe nanometers, 0.456 like that, 1.4 to 1.68, 1.34 to 1.2.45 up to here. Depend on the capability of object observation of light, and it's releasing the energy into the atmosphere. Based on that, the sensor will absorb the energy, and it's directly proportional to that one. If more energy it is released, and it's absorbing by the more, and at the same time, it's releasing into the back, or it's reflecting into the atmosphere, and which is absorbed by the same scanners. Yeah. Here, layer by layer, the image it's going to be created. Depend on the spectral bands and the spectral responses from the ground basis. That means what is our main target? What you are going to capture? Yes, we are capturing in a particular or a limited area. We are capturing the maps. So as per that, layer by layer, it will be capturing and making the images. Resolution. I told you resolution also. Once if you are taking the image, it has some resolution. Example for if you are taking the photograph in phone, either maybe it is a 10 megapixel or a 5 megapixel, whatever. If you are taking the photograph with 5 megapixel, you can check the feature how it is done. And the same feature you can take with 10 megapixel or 15 megapixel, and then the clarity is different from previous one. So automatically the resolution is high. The resolution is high. So here also the same. Depend on the number of spectral bands. Particularly we will use here red, green, blue, and near infrared. Second one it is a mid infrared. And after that, thermal infrared, etc. Radio waves and all those will be available. That means here, based on the observation capability, these three are red, green, blue. These three are playing a very important role when making of an image. Sometimes some images you can see black and white. Sometimes. Sometimes we see color images. But depending on the usage of a satellite. Suppose example for IRS. And again, we can see the Landsat. There is a differentiation between them. In a Landsat, we get the red color is more. In IRS, we see all the colors. Some colors we are not able to identify. Those color composition is called as a false color composition. Called as a false color composition. Yeah, that's only. You see this point, certain spectral bands are combinations which are good for identifying the specific ground features. Yeah, example for water bodies. Water bodies, we see the water bodies in different colors, three colors: blue, dark blue, and sky. Brown, when it is in a drying position, then we can identify if the area it has a dry position. Previously, it has water. It contains water. So when it is in a dry position, slowly what is happening? The water is completely evaporated, and slowly it gets precipitates to the image. So the maybe that will be seen as in brown color. Yeah. Comparison of Landsat sensor. It's a land satellite sensor. I hope last time I told you this also. Yeah. Here there is a differentiation here. You see the first picture. That means this. It's looking into the black and white or a brownish color a little bit, and then the color was applied here in the second one. It's a 2.5 spatial resolution. That means the 2.5 of megapixels. Megapixels, and then here true colors and the pseudo color image. What it is a pseudo color? What it is a true color? Actually, it is a black and white almost, and then the colors will be applied here. So we applied the colors here. False color. Yeah, the black and white, whatever here we are observing, and then along this boundary, it was merged. Again, yeah, wait, I'll explain. See, maybe it's a road connection or a junction, whatever, and the roads is indicating in a black color, and dry lines, the space, whatever it is indicating in the top of the buildings, the roofs, maybe. It is so you can see it is in a white color. Then you come into the pseudo color. Here applied it is in a red color somewhere, red tones. Color means tone. I'll tell you later. That is red tones are red color. Maybe that is a crop area or plantation area. Because of the original plantation, we see on a map it is in green color. It is in green color. It is a pseudo color, so that is the reason it's a converting. It's a converting into the red. That means it's absorbing. Not that's not our priority. The satellite is absorbing right. Satellite is absorbing and applying those colors. You see the first one, the development of image with a different multi-spec. Here only we use only just we will see here the original image without applying of any color compositions here. The water body, maybe you see here it's made water body, it is looking into the block. Then other features. All other features only we can able to see that is white patches. Next coming to the same. It's a 15 meters of resolution and here 30 meters. Now we are applying the bands 1, 2, 3 in RGB 1, 2, 3 red, green, and blue. Yes, we were applied. See. Again, the water body is indicating the same. Just differentiation you see here. It's a dark blue. It is maybe. It's a dark blue. Dark blue. See. Completely, it is in a black color, but when we are applied blue color, then it is absorbing the dark blue. Means maybe it is very deepest. And coming to the next one. Here, some areas you see pinkish color and gray also, and white patches, and again cyan color. Maybe it is a half-K2 area or different. Now we compare from first one, second, and third. The bands are different. Here we used 1, 2, 3 bands in same RGB. Here 2, 3, 4. The bands are different. The bands are different means the color resolution maybe it is a vary from first one, second, third. And last one, the same land satellite Terra model map, and its inclusion of bands. We are using here 3, 5, 4, or 4, 5, 3. The bands are different. The bands are different means instead of 2, we will use here 3 band. It is indicating the blue. It is indicating the blue means the water body is almost the water body. It is indicating a blue color. The maximum these areas, blue color areas, it's a lightly very little amount of water body, only just like maybe it is the streams. Streams are having less depth. Then you see these water body. Is there any differentiation from here to here? Is there any differentiation or not? From here to here. Just very slight differentiation. Yeah, little. Okay, from this one, depend on the band, depend on the color compositions. We are using 1, 2, 3. In the first map, we are not using any one, just a normal map that is in the black and white color. The image it look like only just 2 objects we are identifying here. One it is a water body, second one it is a field of areas or whatever it is land. Next step. In the next step, we are applied 1, 2, 3 bands. 1, 2, 3 bands. 1 it is a representing blue, and 2 it is a representing green, 3 it is a representing red. There is a slight differentiation. We have identified here a slight differentiation from previous one. Then again, same you can apply the third image and fourth one. Here the band levels are increasing. At the same time, the colors also increased. The first picture we indicated any colors. In second, you see here, and third, we see here, and fourth one, some yellow patches also we have identified. These yellow patches maybe it is a crop area. It's also indicating crop area, but the color it is a different here. When we are applying this is the fourth band, yeah, fourth band, and it is converting into the yellow color. Maybe again the red color it is indicating it is a hill area maybe. That is a differentiation from one image to another image depending on the usage of bands. Okay. Yes. Same. Here wavelength. You see here it's mentioning the wavelength, and second one it is a reflectance of objects. 350. It's a nanometers mentioning. 350 maybe it is nearby the infrared, I hope, and then 450, 500 or 550, 560, and 650 nearby the 750, indicating blue, green, red. 0.425 or 0.526 and 0.627. That's blue, green, red. As per that, the observation of a colors different. Depend on that we are using the multi-spectral bands. You see the previous one, okay? What we have observed, one it is pinkish or reddish. You see here pink. What it is observation. It's almost 0.4% is observing compared with yellow. Here, this it is also including with this one. It has a more composition color. That means tonal changes of height. The color composition is of height. So you can see here, suddenly you can see that it's getting more bright compared to the other color. So it's a observation. It's a when you compare with the observation part, it's a more observed by the objects. Yeah, it's also similar to that. Next, what? Near infrared color. In electromagnetic spectrum, maybe I don't know. Yeah. Here you see this map. It's electromagnetic spectrum, and it's showing the electromagnetic radiation. It's a visible light. Almost all visible colors are VGR. It's available between this one. So you can divide this one three parts like that. So, NIR means somewhere here, near infrared, and it's a mid infrared, and then above this one it's a thermal infrared, and after that it is exceeded that area is almost from 10,000 micrometers to up to here. It's a microwaves, and when you come towards right side, it's a 250, yeah, no, 250 250 micrometers. It's a ultraviolet range. It's very dangerous. When you come towards right side up to gamma rays, these are all very dangerous. Alpha, beta, gamma rays it's having, and these gamma rays are very dangerous. Okay, this area it is called as a near infrared. Okay. No. Yeah, it's a airborne terrestrial application sensor. Then Here the sensors will be mounted. It's a moving objects to maintain the limited height. So it's applying the 1, 2, 4 of a bands. 1 to 4 of a bands means only a less amount of spectral bands were applied. So this is a completely related to the atmosphere range, the clouds or whatever it is. Then it is indicating the water body. The blue it is indicating the water body. Second one, it is a greenery part. It's very less, very less part of greenery is covered, and red means there's a mixed composition of the red, light pinkish color. Light pinkish color. Yeah. Same atlas. The range you see here, different bands we can apply. That's maybe completely green. And again, same bands you can see in a Landsat. That's a completely approximately it's 8.2, 9 or 10. The space it is, here it is recognized as an empty space. It's not absorbing. And so showing only just what it is that 1 to 4 bands and 5 to 7 bands. These are all will be useful for identification of objects on the image. Okay, here it is mentioned the different bands are showing the different properties. Example for band 1, 0.452, 0.52 micrometers. It is showing as a blue color. That's what is indicating that. That's only. It's provided increase in the deep penetration of water bodies, and as well as supporting the analysis of land use, soil, and vegetation characteristics also. Land use land cover. Land use land cover means how much land we have used on a surface, and how much land is covered by the natural objects and as well as artificial objects. That's also. Second one, it is a green. The maximum it's absorbing by this green color chlorophyll. I told you in the last, I think first class I told. Yeah, why it is absorbing? Why it is green color plant? Because of it has a chlorophyll treatment, and intertone structure you can see again. Magnesium component it is a high. All magnesium components whatever it have in the object that green color. And next one, it is a band 3. The band 3 is indicating as a red. Yeah, it's a red. Maybe sometimes it's absorbing the chlorophyll, but it's dominating by the magnesium component. Dominating by the magnesium component. That means when it is absorbing, along with the magnesium component, iron will be also there. If iron content is more, then what happens? Magnesium component content will decrease. So that is a reason the red content is showing high. Yeah. It's a reflective infrared. It's a 0.76 to 0.90 micrometers. It's a vegetation of a biomass or a group of plants, and again it's having the soil crop. Soil crop means cropping areas. Rice paddy material is rice. Example for rice. They are going very closely. Going very closely, and it's looking as a mass. one band 6. See here, this band measures which is measuring the amount of infrared and the radiant flux emitted from the surface. Yes, here. Here, the flux, it is emitting the surface. The flux material is absorbing and again immediately emitting. It's immediately it is emitting into the atmosphere. Then the sensors will catch within a fraction of seconds, and it's a making of image. The final one, it is band. It's looking for geological formations. The geological formations may be when it is a forming of geological materials. It's coming from the igneous volcanic material. Lava, whatever it is, reaches the surface. Surface depend on the crystallization stages. Some elements, maybe silicon, oxygen, aluminum, sodium, potassium, various elements. They will be crystallized very fast, very fast. And some gases will be used. Sulfur dioxide, carbon dioxide, including water vapor. Different stages was found different stages. So, same you can see granite formation. Granite formation is granite rock. Sometimes very fine grained material, or some of the materials you can see coarse grain. A fine grain means immediately rapidly they will become crystallization. Or coarse grain material, they will crystallize very slow. Very slow. So at the time what is happening, you can capture that image. The fine material, you can see it is solid, like a solid as a block. The photo is looking blocks. Whereas when you see the coarse grain material, it's like structure. It gets shear and distance on the surface. Tonal changes, as for the tonal changes, I think the color changes different compared with smooth surface and rough surface. Smooth surface you can identify the fine grain material, the rough surface you can identify coarse grain material. That is a differentiation. So these tonal changes will identify the characteristics of a geological formation, and also mention it is a hydrothermal alteration in a rock structure. Okay, it's a different process. When it's reaching to the lava towards surface, then it's a beginning the huge amount of the water body and along with the temperature. So that some elements like nickel and iron is not easily melt. So slowly they will melt. So that what is happening is that turn into the black color. That's what they approximately 7,000 degrees centigrade. Due to these hydrothermal alterations, the rock color composition will be also different. Yeah, next one it is a hyperspectral. Here hyperspectral, the maximum bands we can use above nearby the 10 nanometers. 10 nanometers. Multispectral we can use. Only just we have 1, 2, 3, 4, 5, 10. But when you come into this stage, multispectral or multi-band will be applied, different colors, approximately 256 colors or above 1011 colors will be applied. Just example, you can see the LCD monitor or LED monitor. It has approximately 1,000 colors. And each color you can have your own pixel. I told you pixel is what the pixel. Later we discuss that is also. Yeah. Again, as per our layer wise, we can see here. Oh, it's a one pond. It's giving a picture. true color versus pseudo colors. Based on this one, we can calculate the depth and height of hills. Height of hills. I'm not going to into detail study, only just outline and yeah, temporal consideration based on the seasonal. Based on the seasonal. Yes, you see here spring, the bands were applied here 3, 4, 5. It's in a spring season. And again, you see the same picture in a summer with applying of the same bands. Is there any differentiation from spring to summer? Any differentiation? Yeah, in the first part, in a spring season, you see here, greenery it is more. This one. And some water bodies also. And these lines it is indicating the streams, but which are having very less depth. Here. In a summer season. It's completely different. And next one, leaf on versus leaf off. Leaf on, it's a leaf on. That means the greenery is on the image. When it's a turn of green part, you can see it's completely, it is in almost a brownish color or a black and white color. Yeah, you see. It's a different craters we see here, volcano craters. The Kilimanjaro. The volcano is coming from this one, yeah, Kilimanjaro. Mount Kilimanjaro. And the other side of the forest, the impact of the forest area also that we will. The same picture we have taken Landsat. It's indicating as a drainage patterns. Drainage patterns, I tell you that is also. The changes. The greenery is completely spoiled here. As you can see, no greenery, no leaves, only stems. Yeah, that's impact by the this one. Impact by this one. The what happened? The complete its loss greenery. And final one, it is a radiometric resolution. The radiometric resolution, it's a depend on the sensitivity of sensors and the waves. Every time if you can see image, it's acquired by sensor only. We take the photographs with using of electromagnetic energy here. Electromagnetic energy, after the UVA colors, then the presence of UV rays, ultraviolet rays, from ultraviolet rays to up to gamma rays. These are very powerful and the fact of a second penetrate the object. Alpha, beta, gamma rays. X-rays is second. But gamma ray, gamma alpha, beta, gamma rays. Alpha rays they can penetrate up to 1 meter. beta rays, they can print it up to 100. And final one is gamma rays. They will print it a kilometer. Okay, so you can determine or measure the meaning of portable gamma ray spectrum. Portable gamma ray spectrum and gamma ray common percentage radiation from the surface. Very tiny. Yeah, and these in the presence of those races, the energy, how it is getting the reflection and how much energy it is absorbing by the different objects. And so different types of objects are having different capabilities. And we can study that is in radiometric resolutions. Yep. The final one it is the maximum number of brightness. The levels available depends on the number of bits which are using representing the energy recorded. Thus, it is a sensor used 8 bits maybe. The recording of the data maybe it is 8 bits. That could be as a 2 to the power of 8 approximately. That's the digital pixels having. I'll tell you that each digital number, each pixel has its own digital number. Each pixel has its own digital number. If it is a mix, that digital number, the frequency is going to mix. So that the image lost in their own class. So for example, you can see where last one now. Ah, yes, 11 bits. Now we have a number. So many bits we have. No answer. Okay, once you have extracted the image, the images are available in a different formats. Yeah, what are those formats? Yeah, before going to that, what it is a differentiation between the image and map? I told you so many times that is visual image interpretation, or it's representing anything object. It's displayed on a particular paper. We are calling that a screen or etc. and etc. It is called as a image. Now we have a modern 3D holograms. Maybe it's however a display without base medium. So what's the importance of this digital image? Why we should convert into the digital image? What is the digital image? Hard copy is a difference. If you convert it to the model or readable model, the work is different. No, the number of pixels are different. The number of pixels are different. So image means only the sense of like darkness, whatever it is related to the map. That is called image. Then, if you wanted to edit those images, now you can convert it into the digital mode. Or wanted to study in the computers, you can convert into the images. You can convert into the image. Just for taking the photograph with the mobile. Now it is a digital image. Then the hard copy, if you take the hard copy, that is non-digital image. Non-digital image. You are doing the work on a computer. That is the digital image. You are converting data into the digital image. What for? Edit this image, write this image, for all the purposes. So, for the things. So, for that purpose, different softwares are available in a market. As per that, the data we can convert into the image, digital image, and convert into the digital image. Yeah, image information. Here, the image information. Sorry, okay, no. Image information. Information. Then the information how we are going to get, and then afterwards we convert into the formation model. Formation model. We are calling the image formation. The information is going to convert into sequential for a digital number. So that is then we are calling the image formation. Yeah, the primary concept of an image formation, which is signify the presence of a dots. Dots means again we have to discuss about the pixels here. DI. Dots per inches. Dot per inches. Then in digital mediums, these dots are often called pixels. What is a pixel? What is resolution? It depends. Unit. It has what? It has photoelectric energy. Pixel is called as a photoelectric energy cell. I mean, if you're taking a photograph without a light, how you can tell? Photoelectric energy has photoelectric energy. Cell. It's a cell. Yeah. The pixels for the 2D medium are voxels, that is called as a volumetric picture element for 3D images. Yeah, in a 2D images, pixels we see are 3D images. We can see volumetric pictures. Yeah, then X, Y, Z axis will be creating one. Then only we have a chance to create the 3D images. Again, pixels can be of a single color in an entire image. It's a drawing, or maybe it's a primary colors or a multicolor drawing. Yeah, pixels sometimes maybe it is a single colors. Single colors means black and white. Black and white. Or sometimes maybe it is in the multicolor. Multicolors. The multicolors it's required more energy compared with black and white. The proximity of a pixels dot per inches dpi, and it has a count and it has a dimension, and it's representing as the image resolution, which is a primary measure visual quality of an image. It's definitely pixels are more pixels the pixel sizes are less, are counting the less. Then the picture clarity is low. Yeah, images type S, we know that. So many types. The BMP, GIF, JPEG. Yeah, coming to the detailed study of types of digital images. One, it is there are two types of digital images we have. One, it is a raster image. Second one, it is a vector images. In a raster images, these images were made by the pixels or dots. Pixels, dots are same. Both are electric. So, a raster images means a frame of a screen which is made using the scanning of an entire screen line by line. About just you observe the scanning. The scanning, the roller is moving line by line based on the measurement scale. Depending on that, moving line by line, and it's covering the inch by inch also. And images are resolution dependent on and cannot be scaled up and down or up or down without a loss of a quality. And that's depend on how we are moving the roller on the picture. Based on that, capture and scan it capturing. The next one, it is vector images. In a vector images, we'll use shapes here. That may be line or triangle or a rectangle or a circle or whatever. It's a line there. It's a line. But previous one, it is it's a pixel. Pixels depend on the pixel or down. In vector scales or vector images, we can use here lines or curves or different types of close or association maps will use here. Yeah, so again, both the raster and the vector images, yes, we can see in a colors. Again, based on the dimensions, the digital images, we'll see that is a 2D image, 3D images, and again a 3D image on 3D medium. If the first one, it is 2D images that are seen in X and Y axis. The X and Y axis, but that means only just we can draw a line along the X axis and the Y axis. Yeah, message చాలా వచ్చాయి. Yeah, okay. 3D images on 2D medium. You see here, 3D images on 2D medium. These images that are displayed on a 2D medium, but still have a feeling of a depth association with it. These images might require a viewer to wear a special glasses to feel the 3D effect. 3D glasses, that means actually it is a when we are observing the same things in a with using of a 2D medium, it's a required special yes, it's a required special glasses like example for photogrammetric elements. So there we can use the stereoscope. Stereoscope glasses use and we match the images. And the same features will be joined and the remaining additional features will be joined. That is in a 3D medium also. 3D class we will use. There's three-dimensional pictures for creation. The map we can see as a 3D map. That means, yeah, yeah, that we have 3D map. And third one, it is the 3D images on 3D media. Images that are produced in all 3 dimensions. In 3 dimensions, 3 axes, X, Y, Z, 3 axes, showing. Yeah, image format features. The following features will list out here. One, it is a resolution and DPI. Second one is a color or a bit depth. Third one, it is a compression, transparency, alpha channels, gamma corrections, anti-aliasing, interlacing, pellets, and off-tone, duotone, animation support. These are all the features it's required. Yeah. Resolution and DPI. The resolution is representing the number of pixels. Either maybe it is in the horizontal plane or a vertical. It's a horizontal and vertical means it's a 3D, yeah, 2D, but grids. It's made into grids. Box, small box, grids created. I told you that is in the last class. Just if I have that map, I'll show you also. See the side one, it is indicating the lines. But here you see the cross one, the grids were created, small grids. This one. Yes, it's a grids. These are the grids you can see. If you can zoom again. More grids. Yes. More pixels. That means it's an association of pixels, a group of pixels, and it's made as a grid. Simply you can see how. I'll show that structure also. Yeah, it is a water flow map. Yes. See here, small grids, how they were formed. The plus it is indicating the grids, square shape, uh, square shape. This is a creating as a grid. If you just you can click here, these values are changed. It has one number. The number it is called FFT step number. Every map you can use. Every map has one number. The number it is called FFT step. DN. DN. Yeah. Yeah. The visible quality of an image will also depend on the display of a resolution property. Common computers which are having different types of pixels. You see here, you know that 800 into 600 pixels, 1024 into 768, 1280 into 1024, 2048 into 1080 pixels. Uh, Different resolutions. Okay, we know that we can see in a JPEG or whatever it is. Just a screenshot, it is not. We need JPEG. Okay, leave it. I don't want to time waste. Sorry. Yeah, different use. See this picture, how it changes in different colors. That's maybe in 2 colors, 16 color, 256, 24 bits, or 32 bits, whatever you're using. The true colors or high color settings. I mean, the picture clarity, see from starting onwards here. And again, image compression. When we are to compress the image, and there is a differentiation from first one to the second one. We do the image compression. You can find out any differentiation from the first picture to the second picture. Hmm. 112 kb to 5.6. You see, is there any differentiation? Hmm. I mean, clarity. Okay. Wait. I'm not showing it like that. So I'm not sharing the screen. Again, they lost. Yeah. Okay, if you reduce this file size, can you identify any minor changes? As you see the differentiation, what it is that? Tell me. GIS colors. Again, shade. That's mean the quality is lost. You can compress your JPG image also. Reduce it, or you can increase that. Yeah, image transparency. Image transparency features which are available in the certain file formats. That's depend on that whatever file we are using. As per that, the format it is changes. That may be in GIF or PNG and TIFF formats. The transparency. We lost the transparency. Then in some formats, multiple levels of transparency are supported by adding of external byte transparency. That is depend on the level what we are using. So sometimes we use the RGB colors. It become a RGBA, additional colors. RGBA, additional colors, adding colors. And here is stands for Alpha you can add. We'll add the alpha. Not only alpha, we'll use any additive. Multi-colors in an image, we can use the different colors. Now I'll show you that is. Just use it. It is a image. You see, there are various colors. Multiple bands were applied here. It's nearby the Nagarjuna Sagar area, Nalamala forest, very dense forest and hilly area. The greenery is showing very dense area. Completely it is a hill. And this granitic, that means this red area it is showing as a surface, flat area. Not only not red, they are not indicating red, land, red. Yeah, it's a without forest coverage area. You see the differentiation from here only we are speaking about RBG basic colors. But when you go into the image, the color image, multi-color image palettes. Yeah, it's association of almost 250 colors or around 64K colors or 16.4 image. But again, each color has a pixel. Pixel means photoelectric. So without electric energy, not absorbing or reflecting. And here are some corrections we see. Yeah, gamma corrections. Just you see from the first picture, second and third. Gamma rays if you can send because gamma rays are have more powerful compared with light rays. It's going to very deeper level. It's penetrating very deeper level and capturing the scope. Octone and duotone. So whatever perception is going to be generated with the use of a different dots or pinless. The image it is making by this one depend on their density. Duotone it is producing by superimposing another contrasting color, after over after drawing another color. Suppose we are taking the image, whatever image either maybe it is black and white or in a color. So you can edit or you can draw the same is of a different color. Just I give you image then give you transfer the key you can color it completely and identify the color. Categories. The categories of 2D images. It has a different formats. Raster formats, if you see that is a raster formats, non-proprietary, that's a JPEG, GIF, PNG, TIFF, and BMP, and proprietary, that is a PST and the PSP. Vector image format or vector analysis. Then we can use the CCM, SVG, WMF, EPS, CDR, PDF, and so on. So these are all will be useful to study of different images. How we can draw a map using of PNG and at the same time using of TIFF file. Because of now you are going to the GIS. PNG is not uploaded. Then the format is going to tick file. JPEG, it can upload JPEG. The JPEG is not available. You can convert it. And for rectification and the registration. Image rectification and image registration. Based on these two properties, now we can convert it to the tick file. A tick file is editable. Here, bitmap means bit map format. We used to store the direct pixel for the color information. It is mainly we used in Windows family of operating. How they are using the details. These bitmaps or zip or PNG, these are all the basic operating systems. Basic operating system. Yeah, some points are given here. GIF, it is called as a graphic interface interchange format, and it's also pixel-based format. Pixel-based format, and the image, if it is a not quality, then why it is not quality? You can reduce the size and not the picture is going to last original format. Again, it supports up to 256 colors. It is good for image with line, curves, and solid. Yeah, sometimes we can use the same in the vector analysis. In vector analysis, vector image, curves, line, small images like rectangular shapes, circular shapes, triangular shapes. Yeah, JPEG. It's a giant photographic expert. Giant photographic expert. Yeah, it's also supporting almost all operating systems. And just here, given the picture, you see, if we can, then here also, if we can change the DPIs, that's also going to long version format. These are all the basics. What's the use of all these things? Yeah, this one. Yeah, TIFF file is important for us because of these files. SRF TIFF files we can use in GIS server. The maximum image, all the images can be converted to TIFF files. So this format experts designed for images. Yes. Particular image format we use. So in a different quarters are scanners. That may be a up to 8 sizes we are having. Depending on our requirements, the data is to be converted into TIFF. That means first we can save it to the JPEG basic format, and again, depending on our requirement, then we can convert it into TIFF format. It is supported to software, and it is editable. Then PSD, it's a Photoshop document. All the Photoshop's documents you can use. Your vector formats. In a vector formats, it's a Windows meta file or enhanced meta file. It can store both vector and bitmap components. My question is here whether JPE or JPE format we can convert into, this is formation of GIS. One more thing is whether the format is supported to vectors or not. Vector data or not. Here the main thing is not supported because of all the vector formats. All the vector formats we see in the picture mode. Rectangular this structure types of curves is not used vector, not the raster. The raster into the raster cell type point mode, point type of cell we use raster. The Coral Draw method. Okay, yeah, it's also useful for the vector-based format. The final conclusion, it is whatever the data we are extracted from the different sensors, and the data should be stored, in a vector formation or the final raster. Then we can convert into the station and non-station. Station and non-station. Station it is related to the raster, and vector is related to non-station. Okay, I'm stopping here.